Hey students, this is Mr. Sharp again here for the third video for Unit 3 in Systems for our series in Technology, Engineering, and Design. For this video, before we start anything, I want to let you guys think about an example that kind of will wheel us into the topic for today. So, if many of you were younger, you may have played with a toy brand called Legos or similar products like Mega Bloks, or any other companies that make any kind of interlocking blocks. And if you're like me, I loved them when I was a kid. Even though they were older models, I used to love getting the new sets, reading the instructions, building them per the instructions, sometimes even tearing them apart and making something new. It was just great using all those different pieces and make something new. I loved them when I was a kid. I'm actually waiting for little Mason here to get older so that way he can play with them, just so I can have an excuse to play with them myself. However, we know that Legos is not the only brand out there, as I stated earlier. There are other companies like Mega Bloks, Block Links, whatever you call it, Connects, whatever. Did you know that those companies were actually making their brands based off of the same designs as Lego? You may think this is a little bit of copyright infringement or stealing somebody's work, but it really wasn't. It was all due from a process called reverse engineering. And this is the topic for today's discussion, the big thing for Unit 3.3. So reverse engineering, how is that different from basically what we do here in design and engineering? So in forward engineering, we go through the steps of creating the design first, using the design to build the prototype, test and redesign the prototype, and to finally build the ultimate product that will become the blueprints for manufacturing and mass producing. That's forward engineering. In reverse engineering, we have to take the actual product itself and find out what was the design of that product. So why reverse engineer? So it's not always for illegal purposes like we just talked about. Sometimes it's because we lost the design. Sometimes those plans get lost. Sometimes it's because new features of the product have become illegal or they're no longer in use and we have to update the design. Or sometimes we have to explore new avenues of improving the design. This is part of the research and development process. Hold on one second. My little co-host is going to join us for this next part. So those are the reasons why. So what are those steps to reverse engineering? They really consist of six parts. So the first part is being to predict. So we have to predict what is the actual process of this product, of this design. We don't know how it was designed, so we have to predict how it was designed. Somebody spit up. We have to predict what is the criteria and constraints of that product. And next thing, we have to observe, use the product, put it through the process of you taking this input, sending it through the process, and what is the output. Observe how it functions. The next part is going to be the fun part, which is disassemble. Like if you were just given a new Lego set and you didn't have the instructions, but that Lego set is already put together, you have to observe how was this put together, disassemble it, and then every single part that you take apart, you have to label. You have to ensure that you identify what was this purpose for. Next part is to analyze, being able to identify all the different subsystems of that product. Going back to Lego example, analyze what were those pieces used for in the certain function or the certain subsystem of that entire Lego building set. Finally, you test the product by reassembling it back, making sure that you sketch out the design of that as you go forward. Make sure all those labeled pieces are put in the same way that you assembled it. Test it to see that it has the same results as what you had seen from your predict and observation phase. And then the last part is to finalize the documentation of that design. And that is the basic part of reverse engineering. Sometimes it gets more complex than just simply putting Lego sets back and forth together. It can be something that's very complex as taking a bomber and making the designs for your own. But most of the time, this is what we see how reverse engineering is done on a daily basis. It's done to ensure that smaller material pieces are redesigned so we can make things cheaper in the production process, or if some chemical that's being put into a new product is now toxic or harmful, we have to find out, reverse engineer what the chemical process compound was that was harmful, be able to supplement something new that is safe to ensure that we get the same results as the product before. So that is it for the reverse engineering video. Join me next time for our last video in Unit 3 where we talk about maintenance, troubleshooting, and repair. Have a good day, guys.